Let's get started. Apologies for doing it kind of weird old-fashioned where I don't have a full slideshow. So if I click the slideshow, it's just going to explode for the full screen and then you won't be able to see anything. So we'll have to stick with that. But without further ado, let's start talking about the shape-up process or shape-up methodology for data science and how it actually enables us to deliver data science projects end-to-end from kind of business conception to actual execution, putting in production, full deployment and monitoring in 6 weeks. On the agenda today, we have basically 3 main parts. First, we're going to talk about the challenges with deploying data science projects or with finishing data science projects, and what are the main kind of points where they get stuck, and what are the problems, and what are the differences between data science projects and typical software engineering projects. So we're also going to touch upon Agile a bit here and say why, at least in our experience and experiencing quite a lot of our customers and users, Agile actually doesn't work very well with data science projects. Then we're going to talk about the shaping and principles. So we're going to start talking about the shape-up process, which is basically we adopted a project or product methodology from Basecamp called ShapeUp. They have a very nice free book that you can get on their website. We read it all, everyone in the company, and then we decided to adopt it, adjust a bit here and there, and we've been adjusting it a bit ever since. But right now, I feel we settled on a stable version that works really, really well for developing data science projects. We're going to talk first about the principles, the guiding ideas, or like why behind the ShapeUp, and what are the most important parts of it. And then we're going to talk about the shaping process itself and building process itself. So basically how ShapeUp looks in practice. This part is going to be just a quick overview. And then we have a more in-depth course that you can sign up for later on that goes really in-depth. And I think it takes like 8 sessions. So let's start talking about the main challenge of machine learning models or data science projects. And the main problem is that they don't go to production. There's still quite a lot of machine learning models that are stuck, either in this advanced POC stage where things kind of work, but the data science team needs to do just one more experiment. Or if you try to evaluate it again, turns out actually you had a very subtle but very important data leak. Or the model is done, it's ready to be delivered, but for some reason, it's very hard for the managers to actually push it from the point when you have this advanced prototype that's almost production ready to actually deploying in production. And the reason for that is most data science people are really thinkers and not doers, which is kind of in contrast to the engineers, where engineers, we just love building stuff. Whereas most data science people necessarily don't really like building stuff, but they like figuring things out, which is great for data science because that's what data science is all about. But once you figure out stuff, a lot of data science teams lose motivation to actually deliver things to production. Not all of them, but it's one of the common reasons why models kind of get stuck in this POC hell. And then on the business side, there's also quite a lot of problems. Some of them happen before, and some of the problems really start before the project gets started, and some of them only become visible as we are about to deploy them all to production. The first one is generally sometimes in organizations that are not very mature from data science perspectives, we're going to deal with vague requirements. So we're going to have requirements such as, we need to solve churn, or can we predict something that this something is not going to be very well defined, and it's not going to have good benchmarks, it's not going to have good metrics, and it's not going to have good success criteria. So that's one thing, and we'll of course have a solution for that in the ShapeUp, and of course you can just approach it with open mind and you should be able to solve it, but we have a nice kind of prepackaged solution for that. Then we have unclear success criteria when we don't have upfront agreed ideas of what is good enough performance, what is good enough benchmark, how well this model should work using whatever metric that business and data science team agrees on to make sure that we can actually deploy. And then we also sometimes get into these kind of rabbit holes of like business wants to improve the model a bit, or the model is not really good enough. So even though it would already provide value, we're going to keep on experimenting. And in that case, kind of business and data scientists can work hand in hand to prevent the models from going to production, even though, of course, none of them actually want it to happen. And then the last thing is communication. where data science teams sometimes communicate in a very scientific and technical language, which is quite hard to understand for business. And again, we're going to solve it with ShapeUp. So these are the problems. Kind of continuing why we cannot just use Agile methodology as the answer to that. Agile was basically created as the answer to the waterfall model, where we have a known scope of most complex software engineering projects. So we need to be agile in terms of what we're building, how we're building it. And this works, I would say, extremely well for most data science projects, for most software engineering projects, because indeed the scope is going to change as we keep on building, because we're going to discover new things. But we already know that this project can be done. You can build a marketplace, you can build a website, you can build a SaaS platform. It's not a scientific question whether it's even possible to do such a thing. Whereas in most data science projects, sorry, we actually have a slightly different issue where the scope, generally speaking, is more known than in software engineering projects. So first of all, we generally know more or less what we're actually trying to solve. If we align on the requirements, let's say we want to build a churn model that has certain precision, certain recall, and maybe reduces the churn rate by 2%, that is at least a known scope from the perspective of what is the end outcome, which tends to be not really known for the engineering projects. On the other hand, we have absolutely no clue if it's even possible. Maybe the best we can do is bringing the churn rate by bring down the churn rate by 0.5%. So the scope here is unknown. And that means that Agile, as it is right now, doesn't really fit very well with the data science projects because the feasibility is really not known. And this is something that Agile was not built for. So what's the solution then? Solution is the ShapeUp framework. And just to give you a very high-level overview of what the ShapeUp framework is all about, it basically creates these cycles of 8 weeks where we're going to build things for 6 weeks of focused work, building only specific things by a specific team. And we're going to make sure that the data scientists, engineers, maybe designers, everyone that's part of that team doesn't need to do anything else but just build that specific project for the next 6 weeks. And then this week tends to be very intense. So then we're going to have 2 weeks of downtime where everyone is going to be able to pick up the things that had to be dropped, catch up on other stuff, maybe build things that they really wanted to include in the project, but we decided to remove it during the building phase. And then we're going to do it again and again. And I'm going to start with the kickoff, which is either 1, 2, or 3 days of on-site focused work when we align exactly what we're going to build and how we're going to go about it. Before that, there's also the shaping track. The shaping track is not a track for the team that's building the thing, so not for data scientists, but it's a track for head of data science or data science manager, sometimes lead data scientist, some kind of representative from the business. This should be 2 people at most, and they're in that 4 weeks every time before it happens, before the kickoff, and it can and should be done in parallel with building the previous cycle. We're going to shape, so we're going to define what needs building, and we're going to align on everything with the business. And by kind of this parallelization, we can actually keep on delivering every 8 weeks. We can keep on delivering meaningful work, meaningful new projects, and we can actually deliver them fully in 6 weeks from the point when they are fully defined to the point when they are fully released. Now, in terms of who actually is part of that building team, we need to have representatives from few different kind of categories or different areas of expertise. And of course, it doesn't mean that we need to have always 4 people, 1 data scientist, 1 data engineer, etc. But we can have a data scientist who's also really good at being MLE. We can have a data engineer who's really good at being also a software engineer. And maybe we might need a designer if there is some kind of front-end work that needs to be done to really deliver something that brings value in an end-to-end way that's driven by data science. Or maybe we might want to have more than 1 software engineer because the deployment is very complex. Maybe we're doing something in embedded software. Then we're going to have more engineers. But The bottom line here is that we need to have a team that, without reaching for external resources, can deliver the project in a fully end-to-end fashion. So that's the framework. Now let's talk about the principles. So basically, the guiding ideas that allow us to actually not only have this, basically what looks right now like modified, weird, agile, but something truly unique that works in a way that's really well adjusted to data science projects. And there's basically 5 main principles. First is that instead of having the timeline quite flexible to adjust for changes in the scope, we're going to absolutely strictly, without any room for negotiation, fix the timelines. So we're going to build for 6 weeks, and this is not negotiable. If the project is not delivered in 6 weeks, we're just going to say that this did not work. We're going to start from scratch, or maybe not continue the project, even if it would take 1 day more to deliver. We're going to be unreasonably strict about the timelines here. But on the other hand, to make sure that things actually get delivered, we're going to have flexible scope. I'm going to talk about more in a second. And then we're going to talk about targeting risk first, and why it's a good idea, and why it allows us to actually figure out what are the potential things that would explode the scope. Then we're going to talk specifically about how to remove the scope, and why we should always lean towards removing most scope from the project if we're not certain whether we can deliver something. Then we're going to talk about actually how we should build, and we're going to talk about building in an end-to-end slices. And then the last thing, but definitely not least, is splitting planning and execution. So we're going to talk about how we can separate the planning periods and the execution or building periods, and how we can do it on multiple timelines and multiple kind of time granularities. So first thing, flexible time, fixed timeline, flexible scope. Basically, the way that almost all work happens is that there's 3 main kind of levers that we can pull. First lever is how long will it take? If we take more time, we can do more work. Second lever is how many people we have in the team. And as most of you probably already know, especially if you work in data science for quite a few years, you will know that adding more people to the team does not linearly increases the power to deliver stuff. If you have 3 data scientists in your team and you add the 4th one, it is very unlikely that you're going to be able to deliver 25% faster. The increase is going to be most likely more like 10% more, maybe 5% more. If you get unlucky, you will actually not see any difference at all. So we want to keep the timelines, the resources fixed and reasonably small. The teams should generally not exceed 6 people, and preferably the teams of 3-4 people are actually quite good. In terms of timelines, we already agreed on 6 weeks. The main reason to keep the timeline fixed is that in data science, there is really strong propensity of doing something else, improving the model, making sure it's more robust, testing it a bit more, even more so in software engineering when it's already a problem. In data science, first of all, it's very interesting for almost everyone involved to try out new things. Secondly, it's sometimes very hard to hit the ideal business goals. So again, there's going to be pressure not only from the people that are building that they want to actually try out more things, but also the business. We want to keep on improving things, making sure that it's actually truly robust before deploying. And we need a system that counteracts these forces. And because of that, we're going to fix the timeline. And then the last thing is actually what we're going to build. And what we notice is that a very simple model deployed in a very simple batch processing way, without too many safeguards, that actually just makes predictions, and then these predictions are used by the business, tends to be good enough to actually start providing some kind of value. Of course, once we have this kind of MVP of, let's say, our trend prediction model, then we're going to have to improve it, and improving it is much harder. But if we want to deliver a new project, keeping scope minimal is very good. And even if we want to improve it, then we can also keep the scope, for example, exploring additional data sources, keeping modeling very simple. So the point here is that we want to adjust the scope so that it still provides value, it still is guaranteed to provide value, but at the same time, we can guarantee delivery. Enough about that. Now, let's talk about how we can actually make sure that this scope that is adjustable can still be always fitted or fit in the 6 weeks that we have to deliver. So here, I'm going to give you an example. Imagine that you have two projects, and both of these projects were estimated by a group of very senior data scientists, data engineers, and machine learning engineers to take their best case or their mean estimate was 4 weeks. And at first glance, you could say that these projects are actually going to be the same. Of course, as we start digging deeper, we can look at what are the actual parts of the project, right? We might have talk about the modeling itself, data ingestion, data pre-processing, etc., and a bit of feature engineering. And in the first project, let's say it's a project that we've already done before. It's a churn prediction model. I like churn prediction models today. And we're going to use typical gradient boosting model for that. We already know our data source. The feature engineering is going to be quite heavy. It's going to take a while, but we've already done it before. So it's going to be a long project, reasonably, relatively speaking, but everything there is known. On the other hand, for the second project, we're going to build a very simple, very minimal system that deals with voice to text, let's say, that's going to then be used to predict something about our customers. So here we're going to have to learn a bit more about signal processing, about specific deep learning architectures that allow us to work with the voice data, which the team doesn't really know much about, but they read a few papers, they looked at PyTorch implementations of some things, and it looks quite reasonable. The data is basically already pre-processed, but it's a third-party data that we haven't seen before. And the feature engineering should be quite trivial because we just plug in the data we approach with a standardized way to process voice data. We put it in deep neural network and we click train, and hopefully everything converges nicely. So it's a smaller project. It seems quite easy, but the team hasn't done any of the things before. So they add a bit of leeway here and there because they haven't done it, so there's additional risk. But now, if we look at it from this perspective, this more granular perspective, when we look not only at kind of the point predictions, but also at the risk, we can end up with something like this. The first project is going to, on average, best estimate take 4 weeks. And if things go really, really well, it's going to take 3 weeks because the feature engineering is just so annoying and it will take ages. If things go badly, it might take 5 weeks because we already know what's going on here. On the other hand, the second project, if we get lucky, everything works, we try the first architecture and it just converges very nicely, we're going to be done in 2 weeks and it's great. On the other hand, if we actually realize that this just doesn't work as we expected, or we actually don't understand how these models are supposed to be trained, or the data is actually not usable or much lower quality than we expected, it might take us more than 10 weeks. So if we look at it from projects from that perspective, and we decide to include both of those in our cycle, let's say instead of 4 weeks, they would each take 3 weeks, we should definitely start with the second project to find out whether this project is doable. What are the hardest parts? We should start looking at the data. We should start thinking about how we can put that data in the model before we touch anything about project one, because all the risk, all the uncertainty lies with the second project. And by addressing this risk early on, we'll be able to see whether we need to remove the scope. Maybe we need to completely put the second project on hold to make sure that we deliver the first project. So this is why we should target risk first. Now, summary of what basically I just said. First of all, it's impossible to estimate the workload perfectly. Even if we plan it really, really well, even if we shape it really, really well, we cannot estimate the workload fully. There will be things that pop up here and there. So if we first look at the things that are the most risky, we'll be able to see if they take 1 day, 1 week, or 1 month. So it will help us estimate this total workload. And if we see that it was supposed to take 1 week, but it's going to take 1 month, then maybe we decide to remove some other scope or change the scope of that specific risky part of the project. How do we do it? How do we actually remove the scope? So basically, why scope hammering? The first thing is that we have an initial estimation of 6 weeks, and at the beginning of week 3, we realize that there's some additional things that popped up here and there, maybe with the integration, maybe with the modeling, maybe we realized that streaming is not going to work and we need to work with mini batches. There's something else that we'll have to do. And then there's 2 weeks of additional work. What can we do with that? First of all, we can just decide that we can still squeeze it in. It's really important. We put it already in the scope and business expects that. And in that case, we're going to try to squeeze it in. Chances are we're not actually, we won't be able to actually deliver something in 6 weeks. And chances are, again, that this will keep on extending and extending. So instead of delivering in 8 weeks, we might end up being able to deliver in 10 weeks. But by then, the requirements might change. So we want to really squeeze it in 6 weeks. Another option is to hammer the scope, basically literally look at it at the scope as some kind of sculpture, and we're just hammering away parts that are not absolutely necessary. And here, what we want to do is we're going to remove everything that's not absolutely necessary. And if you really look at it from the perspective that we really cannot exceed the 6 weeks, you will realize that there's way less absolutely necessary things that you expected at first. Maybe we don't need to actually look at second data source. Maybe we'll just look at one data source, build something that's not great, but it's going to provide some value. And again, quick summary of that. Scope hammering is basically adjusting the scope whenever estimated timelines increase. And we should look at these estimated timelines at the beginning of every week when we basically go through of what everyone is working on, how is it going, and whether we're still on time. This helps us to ensure that we do deliver on time, because when inevitably things expand in scope, we'll be able to actually remove that scope to keep on delivering things that actually matter and actually bring business value. And we should always err on the side of removing too much scope, because the scope is always increasing a bit. So if we remove it so much that we actually end up delivering in 5 weeks or so, we think, we'll probably still end up delivering in 6 weeks, because there's always a bit of documentation that needs to be done that we forgot to include in the scope. It happened multiple times to us. What else can happen? Maybe we actually really need to test it more than we tested it, because we found out that it doesn't work for a specific population at all. So always err on the side of removing too much scope rather than too little. Now, in terms of how we actually want to build the solution, imagine that we're going to have basically a project that's kind of a matrix. We have the first part, which is everything that's related to business case, scoping, and things like that. There, our main model that we want to build is churn prediction. But what business actually wants is not just churn prediction. They want churn prediction plus being able to estimate the retention uplift. So how many people we can retain more based on the churn prediction models. Ideally, to make it truly actionable, we actually want to also optimize the retention campaign, because just saying that this person is going to churn doesn't actually automate the entire part. It automates only a small part of this entire business process. And actually what we want, on top of having, let's say, predicting churn a month ahead, we also would like to predict churn a quarter ahead, a year ahead, a week ahead, so we can, for longer time horizons, include that in our financial plans and expansion plans, and for smaller time horizons that we can really target in a very nice, very targeted fashion. We target in a targeted fashion all the people that are likely to churn. And then for data collection and processing, we can use the customer data, we can use marketing campaign data, maybe we can use additional web data that we have access to, third-party data, etc. For model development and training, we can go with simple ensemble methods. We can build a generalized linear model baseline. There is a very nice reinforcement learning paper that we learned about that uses reinforcement learning for churn modeling, because it's a dynamical system in the end. And maybe we want to try deep learning. For model evaluation validation, we have typical scores, precision, recall, accuracy, etc. Maybe we want to really communicate our metrics to the business. So we want to express it in some kind of expected dollars saved for the project. Maybe we want to conduct a live data pilot. And ideally, we'd like to also see those lift charts that show us how strongly we are expecting to increase retention based on the model performance. These are all very important things, of course. And then when it comes to deployment monitoring, we can use batch inference, we can use streaming instead of that, or maybe on top of that for the really short scale prediction, really short time scale prediction. Of course, we need to monitor the model performance to make sure that things are going well. And we need some kind of retraining loop when things inevitably go wrong. And if we do all that, this is going to take 6 months. So what we're going to do instead is we're going to focus on a very specific, absolutely minimal thing that is not sustainable. It is production ready, but it is bound to fail sooner or later. And that is completely fine because we need to build it, we need to deliver it, and then we're going to iterate on it. So instead of making sure that we fulfill all the business expectations, we're going to take the smallest thing that's actually useful, which is just predicting the churn. We really need the customer data for that, of course, and we need to have marketing campaign data to get our target to see who has churned. When it comes to model development and training, we're going to focus only on kind of the golden standards for churn modeling, which is using ensemble methods, gradient boosting, etc. When it comes to model evaluation validation, we're going to only do precision recall, etc. So we know how well the model is working, and we're going to deploy it in the simplest possible way. And this probably will take like 3-4 weeks. Now, we also have things that are really strong nice to haves, and we absolutely want them to do it. But these are the things that might get hammered, might get removed from the scope if we realize that there's something wrong with the data, for example. So here, really, really important things is communicating with the business, what is the impact of the use case, because that helps us, first of all, confirm that the use case actually makes money. And secondly, ensure that this project lives on, is continued, and that we are recognized for our work. And of course, we need performance monitoring because we want to know whether this model actually works well in production. And these are the things that if we end up removing them, either somebody might end up doing them in the downtime, or we're going to put them in the next cycle to make sure that these things are there. But we can still technically deliver a project that's working without them. And then just looking at this matrix, we can already say that we're not going to focus for sure on everything here that's in red. Because these things are not MVP. They might be useful, might work better, might improve model performance, might give us more insights, might make the production system more robust, but it's not important right now, and it's not absolutely essential to deliver value. That's it. Again, summary. It helps discover and resolve risk on the connection points if we build in end-to-end slices. So we're going to build only the minimal thing, and we're going to build it one by one instead of building everything in one part, then moving to the next part. It also ensures that even if we build the smallest possible end-to-end slice, so we're going to build this thing here, then we still deliver value, even if we are not able to fit anything else in. If we focus on first taking all the data, pre-processing, combining it, we might actually wake up at the end of week 5 without having done almost no modeling, no evaluation, and no work on deployment and monitoring at all. And it also, of course, also avoids wasted work because basically everything we do is going to be used because we're doing so little in a way. Then the last principle is splitting planning and execution. The idea here is that the way we think when we plan is different than the way when we execute, when we build. When we're planning, we want to think slightly high level, we want to consider what we're doing. And we want to formulate a plan that then we can execute on. So planning is also work. And then when we execute, we don't want to think about what we're doing, how we're going to go about it. We just want to get started, and switching between this planning and execution is something that I noticed not only for me, but for literally everyone I ever worked with, creates a lot of mental fatigue. If you wake up and you don't know what you're going to work on, you're going to waste a lot of mental energy figuring out what is the most important thing that you need to work on today. Then if you get started on it and you actually don't have a plan of how to execute it, again, you're going to have to stop and think what you actually want to do. You'll work for 1 hour, hit a roadblock, you're going to stop and think again, and it will take a lot of mental effort to juggle this planning and execution. So what we do instead is we're going to shape, so plan, on medium to high level what exactly we want to do. Example shape would be basically this, and we will already define that we want to focus on only churn prediction using these data sources, this kind of models, or maybe this model and potentially other models, and we want to do these 4 things here. That would be a potential initial shape. Then we're going to do the kickoff, which is basically transferring the high-level plan from the shaping team to the building team. And then the team becomes not only aware of the plan, but also iterates on the plan and goes deeper into potential things that are risky. So we're going to try to, again, target the risk first already during the kickoff, talk in depth and sometimes in almost unnecessary detail about the things that are really important, but might be very small. And then we're going to build. And building is going to, again, be a mixture of planning and execution, but it should be a mixture that's split in time. How does it work? So basically, the way we do it is we have weekly plannings every Monday that take generally half an hour, and then everything else is for building. We have spontaneous meetings here and there. Sometimes there's going to be a review meeting on Wednesday to align on the details to show what's going on. We don't have daily stand-ups. We don't really talk about progress apart from weekly meeting. We let the people build. Because if you're a data scientist, one meeting a day can already ruin your focus. So that is it when it comes to these high-level principles or medium-level principles. Now let's talk about the actual process a bit more in detail. So as you already know, we're going to start with the shaping process. So in kind of week -4, so 4 weeks before the kickoff, we're going to have a shaping team of maximum 2 people. The reason for that is we want to move fast here, iterate fast, and just exchange ideas in a way that doesn't need to be very structured. Generally, this needs to be a head of data science, or head of machine learning, or data science manager, however you call the person that's kind of owns or manages the data science part of the organization. And then we're going to have one relevant business stakeholder that can act as at least partial decision maker and the expert from the business side. So here would be, for example, head of retention. And for the first 2 weeks, we're going to work on specific shapes. We're going to figure out, and again, full version of what that shape is going to be in the full course. Here, I'm just giving a quick overview. Once we have that, once we have this shape defined, which normally is a document of few pages, we do it in Notion. There's always pictures, there are lists, sometimes a bit of free text, things that are specifically out of scope, things that are very important, what is the goal, etc. Then we're going to take all the shapes that are created across potentially different business units, different business lines that the potentially centralized data science team needs to do. If you have data science teams that are specific to a line of business, then you generally be working with just one stakeholder and potentially creating multiple ideas for the things that might be very useful and very impactful to do in the next cycle. Then we're going to vote on shapes. Voting means that we invite all the decision makers. So in big organization, it might be inviting your N+1, N+2 people that actually make decisions. It might also be inviting engineering leaders, basically everyone who needs to give a green light to make the project a go. And we're going to go through the shapes, and then the decision makers and the shaping team are going to vote in however you decide on what gets prioritized in the organization. It might be just one person making decision. It might be more collaborative process. Here, there is no point of trying to, reinvent or change how it works, because it's basically impossible. So just make the decision there based on potential ideas for the shapes. And then once that happens and we've chosen the shapes to work on, we're going to review them with the building team to make sure that the building team understand what's going on. And of course, building team should be involved in the shaping process when the shaping team is going to ask them questions about specific ideas or details. Anytime they're not sure how to do something or how long it takes, they should talk with the building team. But at the review part, the building team should explicitly read all the shapes, ask all the questions, everything that's still uncertain. So we're ready for the kickoff and we can go really into small details during kickoff. Now, when it comes to the shaping rules, the shaping kind of overview, One very interesting idea that I was absolutely not on board with initially is that you should only plan for one cycle. The reason for that is as following. You only need to know what's going on for what you're going to build for one cycle. So there is no reason to plan further ahead from the building perspective, from the data science perspective, from the product perspective. Secondly, if you plan only for one cycle, then you actually stay extremely agile on this kind of medium time scales. You can completely switch focus from working in churn to working in manufacturing part of your organization. That's completely different. And it allows us to not be overly committed or overly invested into certain projects because they are not planned for. You didn't put work in that as a head of data science. You don't have emotional attachment to it, and neither do the business stakeholders. Second is that by default, projects last only one cycle. That's another one of these unreasonably rigid ideas that works extremely well in practice. And here, the reason behind it is that if you say that, yeah, this project, we cannot fit in that cycle, but we can always finish in the next cycle, then you kind of go back to agile. Because then your timelines are not actually fixed, and you'll end up taking basically 2 or 3 times more than you would if you keep the project specifically to one cycle. There is this saying that the work fills in all available time. So the less time you have, it doesn't mean that you're going to do less work. You just need to keep the time fixed. And keeping the projects to one cycle is part of that. Of course, it's not a hard rule. So if you see that the project is still worth it after one cycle, then you can compare it explicitly and directly with other projects that you could be doing now, with all the risks that you know, and knowing that this project is much harder than you expected it to. And if you still believe that this is the best project to work on, and not only you, but the decision makers, then you can continue. But having this explicit stop and the restart that needs to be manual helps to avoid the sunken cost fallacy and helps us actually deliver on something that actually matters right now and not something that mattered 4 months ago. And last, very practical idea that we came up with. Sometimes when we just look at the problem that we need to solve, we already know that there is no way we can even finish research in 6 weeks. So then what we do is we kind of bet 6 weeks on doing research on a very challenging project. For us, it was performance estimation, trying to estimate the model performance without knowing the target data, just based on the model inputs. Seems impossible. So we were not sure if we can do it in 6 weeks. And then what we did there is we're going to allocate 6 weeks for research. After 6 weeks, we're going to see how far we are. Do we have a working solution? If we do, then we can start talking about putting it into deployment or deploying the model. If not, then we have to explicitly decide if we want to continue with that, if we want to spend another 6 weeks on research. Now, kind of one of the last things, I think, when it comes to this kind of middle level ideas about shaping up is the definition of done. It's one of the key concepts here. Basically, the idea is that the project needs to be truly done by the end of the cycle. And done here doesn't mean that the POC is working, doesn't mean that things are evaluated and kind of stable. We have a specific definition, and the definitions follow. It's evaluated in a strict and scientific way by the data science team. So it works well on an unseen test set that data science people actually did not look at before, and definitely did not use for hyperparameter tuning, etc. So we have explicit evaluation used agreed upon metrics and benchmarks that are agreed upon beforehand. Then it is tested by the software engineering team. So the actual machine learning system that the software engineers and machine learning engineers developed to deploy the model has been tested. We are not obsessed about testing here. We're not doing test-driven development, but there needs to be a reasonable amount of tests so we can say that this will most likely work reasonably well in production. Then, of course, it actually needs to be deployed in production. It needs to be running. It needs to be directly usable right here, right now, by the end user. It needs to be documented. So if something is unknown, weird, not easy to understand, there's some form of documentation that end users can refer to, and that also we can refer to when we improve on the machine learning system. And it needs to be monitored. And here we mean at least performance monitoring. So you know what is the expected and real performance of your models by using the agreed upon metrics that you agreed upon with the business. And then when it comes to putting that in practice, again, we're going to have this part split over multiple sessions in the main course. Here, I'm just going to give you a very quick idea of how we split it. First, we start with project definition. When we talk with the business, we figure out what we actually want to do. This is part of the shaping. Then we do the scoping when we create the actual shape. Then we have the kickoff. And then once the building, the cycle actually starts, we're going to talk about data collection and validation. Ideally, we already have the data, but it really doesn't need to be validated. Then we're going to talk about metrics and benchmarking. And we only start that after we have explicit data acceptance, when we say this data is good enough to work with the labels are there, the labels are real, and we have enough data to have at least some kind of hope that we can do something with it. And we understand the data. Then we talk about the metrics and the benchmarking. These should already be touched upon in the scoping. So there should be some kind of benchmark outlined and some kind of at least idea of what are the metrics that are useful. And now, having seen the data, we're going to fully agree upon what are the metrics, what are the benchmarks, what is something that we think is achievable. Then we enter the prototyping testing loop, when generally speaking, data scientists just split, read things, try things out, create solutions, and then the solutions need to be always created in some semi-standardized way that can be evaluated head-to-head, apples against apples. Then we're going to evaluate them. And then once that evaluation is positive, we have a go, no-go decision. And if we go, then we deploy it and we start monitoring. And if something goes wrong with monitoring, then we go back. But that is kind of outside of the scope for today's presentation, for sure. So last slide, I think, or second to last slide, summary. What have we learned today? First of all, we now understand how data science projects differed from software engineering projects, and the main key point here is feasibility. When we know that almost all software engineering projects are possible in theory, whereas for data science projects, that is definitely not the case. Then in terms of summary of the shape-up methodology, we work in 8-week cycles with shaping beforehand and building, and they happen in parallel, and we have 2 weeks of downtime to recharge and work on the things that the team members really want to work on. To make sure we do deliver in these 6 weeks, we keep the scope flexible, but we keep the timelines absolutely fixed. And to manage the risk and to target the risk first, we're going to split planning and execution on multiple levels between shaping and building, and between weekly planning and execution to manage the risk, to remove or at least to reduce the risk as much as possible. And we do have to follow a strict definition of that. That is really it. If that was interesting, if it built your appetite for how to actually go about it, do sign up for our Maven course. It's already there, and it's hosted by me and my co-founder, Hakim, who's the CEO at NaniML, and he also got his hands dirty as data scientist for quite a long time. You can sign up here with this QR code, and we can have a bit of a, lots of stuff in the chat. We can have a Q&A session now.